Good morning, Amy. How are you doing?
Hi, sir. I'm doing well. How are you?
Very good, very good. So we are working on trigonometry, compound angles.
Right.
Did you try some questions from your book?
Yes, I did quite a bit because after a while I started like kind of getting into the gist of it. So these are the couple of things I've done.
Very
All
beautiful.
here. Thank you. Yeah, layout. I try to make it as clear, like, when you do it in lesson, really nicely laid out, because then when I need to go back and check, it's nice and easy as well. Yeah, and like you said, after doing a couple questions, I didn't have to actually sit down and memorize the equations. After doing it, it just kind of gets instilled in your brain. So that's good.
Yeah, it was good to see that you have that formula list on the top, which was for sine A plus B and cos A plus B, right? And
Yeah, I did that there as well.
yeah, that's very good to begin with. And then you get all the formulas derived. Now it becomes very simple to do most of the questions from the book. I hope you must have realized that, right?
Yes, I did. Yeah, definitely.
Correct. So trigonometry is easy if you systematically approach it. Now
Yes.
let's look into the other important application of these formulas. We call them simple harmonic motion or simple harmonic equations, depending on how they are being applied. But they find wide variety of application in most of the cases. For example, if you take a spring, that is a simple harmonic motion, right? Pendulum is a simple harmonic motion, just keeps repeating like this. So all these are simple harmonic motions, and they can be modeled with the compound angle formula, which we just did.
All
So
right.
if we combine sine and cosine function, we could actually model most of the waves, right? Most of the
Oh,
periodic waves, yes.
right.
We'll see how in today's lesson. So let me share with you the screen, and then from there we'll begin. See my screen now?
Just loading. Yes, I do.
Perfect. Can you please read the title?
Yeah. So simple harmonic wave equation.
Correct. So what we did earlier was compound angle formula, which is written on the side. So these four basic formulae, you should always keep them on the side so that you have a look at it and you kind of get them. I mean, I'm not saying remember, but it'll form an image in your mind.
Right.
Sine A plus B, which is sine A cos B with a positive sign cos A sine B. Sine A minus B, the middle sign becomes negative, sine A cos B minus cos A sine B. In case of cos A plus B and cos A minus B, we have two cosines together and the two sines together, right? Cos comes first.
Right.
So cos A cos B minus sine A sine B. And when it is cos A minus B, then you have plus in between. So these are the four basic compound angle formulae, which you should remember. From them, you can actually derive rest. Today, we are going to talk about simple harmonic wave where we have combination of sine and cosine. The general equation will be of the form A cos theta plus B sine theta. Now, this kind of an equation can be written as R cos of theta minus alpha. So every equation which is combination of sine and cosine can be actually written as just a cosine function as shown here, R cos of theta minus alpha. So we'll keep R as positive. I'll give you the reason just in a second why this is positive. Well, we'll also derive a formula. How do we convert equation of the form A cos theta plus B sine theta into R cos theta minus alpha, right? So basically, on the right hand side, you have a cosine wave which is transformed, horizontally shifted, correct? So as you can see here, the cos starts with the maximum, correct? So you see it has been shifted some units to the right.
Yeah.
That is what the value of alpha is, correct?
Right. Yeah.
Shifted right by some units, and that is alpha. R basically is the amplitude. So basically, R value will be, if you go from the axis, how far you are to the top. So this maximum gives you the value of R, and this value is alpha. Is this clear to you?
Mm-hmm.
The phase shift, right? So this is not infinity, this is alpha, right? So, okay. So that is how they are related. So, and it looks like a sine wave, as you can see, sine or cosine, whatever. Remember one thing, that in the books, we always refer to R cos theta minus alpha. However, we could write it in any form. We could write also as sine theta minus alpha, you understand?
Mhm.
Or it could be theta plus alpha, or it could be r cos theta plus or minus alpha. It could be any form. You get my point, correct?
Right.
And if the wave is kind of starting from the negative, if you want to write, you could also write this with minus or plus. So we have all these combinations. R we always say that R is greater than 0, right? We say amplitude greater than 0. If this wave is kind of like this, you want to model this one, you may say minus R. Is it okay? Minus means the wave has been reflected. Do you get this common thing?
Yeah, that's clear. Is that equation there, the A cos theta plus B sine theta? That's given the question because that's not, or is it one of the compound angles?
No, this
It's
is,
not.
you have to remember, this is your reference.
So the question, the equation that you've highlighted on the left-hand side, is that just given in the question?
Yes.
Oh,
The
okay.
question we will now see related to the simple harmonic equation as A cos theta plus B sine theta. For example, well, look here. There are 4 examples here. Can you please, can you please see what is this? 3 cos theta plus 4 sine theta. You see that equation?
Yeah.
So let us say we are given this equation. Since it is written in terms of theta, we'll call it a function f of theta. Is that clear to you?
Yeah.
Now the question could be, write this equation in terms of r cos theta minus alpha. You get the idea. That could be the equation. I want f of theta to be written as r times cos theta minus alpha. Is that clear to you?
Yes. How would you do that?
In that case, what you need to find is, you need to find what is r and what is alpha, right? Then you can write it. Is that clear to you?
Right. Yeah.
So that could be a question. So coming back to where we were, so in general, we would be given an equation which will be like A cos theta plus B sine theta. You may have to write it as equivalent to r of cos theta minus alpha, where r is greater than 0. This particular equation on the right-hand side is referred to as simple harmonic wave equation.
Oh, is that like standard?
Yeah, this is
Oh.
standard name. Yes.
Okay.
Actual values you can calculate very fast. The formula is given to you. R will basically be equal to square root of a square plus b square. So this R is a square plus b square square root, and tan of alpha is b by a. So for these constants a and b can be directly plugged into the formula given here,
Oh,
and you can directly find the equation. You get the idea. So simple.
that's nice. Yeah.
So this is kind of like this. Is that clear to you?
Yeah. Really clear. Okay.
Questions related will be find the maximum, find the minimum. We also say range, correct? Difference between them.
Yep.
Find the period and sketch the graph. These are the related questions on simple harmonic motion, which you may normally get in your question paper.
Right.
So you get the whole concept, right?
Yeah, very clear.
As you can see, equations could be of the form combination of sine and cosine with some constants. 3 cos theta plus 4 sine theta, 5 cos theta minus 12 sine theta, square root 6 sine theta plus square root 3 cos theta, 2 sine theta minus square root 5 cos theta. These are the 4 equations which today we will discuss.
Okay. Yeah.
In different ways when you get them in your test paper. So these are the basic type of equations. So we could have any parameters for the value of a and b. So these are the values for a, and this is for b, for example. Is that clear to you?
Yeah. Yeah.
You would actually directly also apply the formula, get your result within seconds. You could do that.
Yeah.
But first, let us try to understand what fits best, right? Because there are combinations, as I said. You could write in terms of both sine and cosine. You could write with r positive and negative coefficient. Is it okay?
Right. Right.
So let's take these examples one by one. Today, I've taken most of these examples with degrees. So you could actually have in radians also or in degrees. but we are working today in degrees. Okay.
Do we need our calculator or?
Now you calculate in degrees today for today.
Okay. Yep.
So this is a general solution. How do we get this formula that R is equal to A square plus B square and tan alpha is B by A, right? So what we do is we are given this equation, which is A cos theta plus B sin theta is equal to R of cos theta minus alpha. So what is cos of A minus B equal to? As you can see in the compound angle formula, cos of A minus B is cos A cos B plus sin A sin B, correct?
Yeah.
Now, if you compare cos A cos B and sin A sin B with what we have here, what can you say? Well, you can say, well, A could be cos A, right? You could say, so that means this can be A and this could be B, right? So if I make cos A as A and sin A as B, I get the same equation. Do you see that?
Yes. Yeah.
Very simple. So that means I could substitute A as cos A and B as sin B, sin A.
Right, right.
Correct? That's what I did. So I know the expansion of the right hand side is basically what? R times, right? I have to just multiply this whole equation by R. Is that clear to you?
Yeah.
Then what I get is cos theta minus alpha. Theta and alpha like A minus B, right?
Yeah.
And I know that we are given one parameter, the other one I can assume to be equivalent to the constant value, which is the coefficient. Is that clear?
Yeah.
What I've done here is right hand side is given to us as R times cos theta minus alpha. I expanded cos theta minus alpha and wrote it in the brackets. Opened the bracket, writing it as cos R times cos alpha cos theta, R times sin alpha sin theta with addition in between. Now, if you compare this with the equation given to us, the only thing which we figure out is that this A should be equal to R cos alpha, right?
Yeah.
And this B should be equal to R sin alpha, correct? So we did a substitution. So left hand side is A cos theta plus B theta. So we said, well, let A be equal to R cos alpha, B be equal to R sin alpha. So I did that substitution. Is that clear to you?
Yeah, yeah.
I matched my left hand side with the right hand side. You get the concept, right?
Clear, yeah.
Now clearly, if I square A and B and add them, A square plus B square is what? R square cos square alpha plus R square sin square alpha. We just square these things, correct?
Yeah.
R square is common, cos square alpha plus sin square alpha is 1, right?
The trigonometric identity, yeah.
That trigonometric. So this is being multiplied by 1 only, right? So basically, you have R square equals to A square plus B square, or R is equal to A square plus B square square root. Is that clear to you? So we got this formula. How directly we can use the formula, but simple systematic derivation of the same. Now to find the angle alpha, I'm just saying what is the ratio of B over A, because B is sine, right? So tan is sine over cos. So what is the ratio of B over A? It is R sine alpha over R cos alpha. R and R cancel. We get tan alpha on the right hand side.
Sine and cos is tan. Yeah.
So alpha is tan inverse B over A. So we get our formula that in general, R will be equal to square root of A square plus B square, right?
Yep. And alpha.
And alpha is equals to tan inverse of
B over A.
B over A. When the given equation is of the form given to us right there. Is that clear to you?
Yeah.
Simple as that. So if I give you an equation which is exactly like above, that means plus here, right? Then that is the case. If I have minus here, then this will be minus B, right? Do you understand? B will be negative value in that case.
Yeah, yeah.
Right? But you get the same formula, right? So any equation in a combination of sine and cosine can directly be written as R cos theta minus alpha. Is this clear to you?
Yes.
Perfect. Now, sometimes in the questions, we want to write the equation in terms of sine also. So sometimes they'll say, well, my equation is actually equal to r sine theta plus alpha. You see that sine theta plus alpha now, right? So the question could be that this left hand side is equal to sine. Now, what is the left hand side? We want sine theta plus alpha. Let's look into this formula now.
Yeah.
So here you see very clearly that I could get this formula provided I make sine A as A, right?
Yeah.
And substitute for B
Sine cos A.
get the idea, right?
Yeah.
So we have done that substitution here. You see that? Sorry. So we are saying A is r sine alpha, B is r cos alpha.
Because you expanded. Yeah.
And did the same thing, square and add them. So we get r square is a square plus b square. So r value is same. Whether you use sine or cosine, r is same, which is square root of these coefficients square.
Right.
And the ratio, because we want sine on the top, so this time a over b. Do you see that? Because a was r sine alpha. So whatever, it depends how you define your parameter.
Right, right.
So sine alpha over cos alpha is tan alpha, which is a over b in this case. So tan inverse of a over b gives you the angle alpha. Is that clear?
Yes, it is.
So you don't really have to remember these formulas, but the thing is, if I want sine theta plus alpha, then it is combination of sine and cosine, right? When you add or subtract. So
Yeah.
accordingly define your variable, use your compound angle formula, get the result. Right. So now let's take examples. So we'll take those 4 examples one by one. So here is the very first one. Can you please read the question?
Yes. So f of theta equals 3 cos theta plus 4 sine theta. Part A, find the range of f of theta. And part B, find theta, where theta is in between 0 and 90 degrees, both included, when f of theta is the maximum.
Yes. So basically, for the curve, we have to find the maximum point. That's the whole idea, right? So, what we could do is, we could write this in terms of sine or cosine. Is that
okay?
Clear?
Yeah.
Use any concept. But standard is to write it in terms of cosine. Is it okay?
Okay.
Because
Yeah.
cos gives you a lot more flexibility. So what will happen? If I want to write this in cos terms, right? In that case, I should divide 3 and 4. 3 should be cos of alpha, right? And 4 should be sine of alpha. Because in cos expansion, you know that a plus b, let's write down the formula here, cos a plus b, for example, right? Will be what?
Cos A.
Yeah.
Cos B.
Yeah.
Minus sine A sine B.
Perfect. So, but we need plus. Since we need plus, that means this should be minus, right?
Yeah,
then
that'll be plus.
So we have to use that particular formula. Is that clear to you?
Yeah.
If I want to use this formula, then 3 should be equal to what? 3 should be equal to cosine, right?
Does it matter which?
No, then you cannot apply the formula. So because we have cos theta times something. So cos theta times something is cos A, right?
Wait, does it matter if I do cos B as A?
No, you can write ABCD, doesn't matter. Because the question does not say that we want theta minus alpha, right? The question says just find the maximum value. How do you find the maximum value? Maximum value you can find when you can write this combination of sine and cosine as one single ratio. Single. Only then you can find. So basically, we are indirectly telling you to write it in the form of r cos theta minus alpha, but we are not putting it in the question. It is implied.
Oh.
Otherwise, you cannot find it.
I was going to say, yeah, that'll be hard. Okay.
The combination of this wave is a simple harmonic motion that you should know. And the equation for simple harmonic motion is r times cos theta minus alpha.
Right. Okay,
So
got it.
that is not given to you here. You get the idea.
Yeah, so you need to know that. Okay.
You need to know that. It's not a direct question. The question is to only find the range or the maximum value.
Yeah.
So that becomes difficult. So now you think like this. We could write this in terms of cos function, a plus b formula.
Yeah.
If I want to use plus in between, that means a minus, right?
Yeah.
So if I want to write plus in between, So then I'm writing A minus B formula, right? Then I get plus, correct?
Yeah.
Which is cos A cos B plus sin A sin B. Now,
Mhm.
cos theta times 3, that means this 3 should be a cosine term, right? 4 sin theta, 4 should be sine term.
So cos A is the one that equals 3.
Yes.
Yeah. So
So we
when
say
you wrote
R.
cos alpha,
Yeah. So we say, see, cos value will be always 1 or less than 1, right? Cos cannot be more than 1. But it is 3. That means it is multiplied by some factor, which is R, the amplification factor.
yeah,
So we say R cos alpha is 3. So 3 is made as R cos alpha and 4 is written as R sin alpha.
makes sense. Yeah.
So that is a substitution.
Wait, so how come you used alpha instead of like A and B?
You can use A and B. You can use A.
Oh,
and B.
okay, it doesn't matter. Okay.
Yeah. In that case, in the formula, if you want to use A, you write A here. Is it okay?
Yeah.
But alpha is standard.
All right.
When you talk about simple harmonic motion, alpha is standard. So let us use this standard. Is that okay?
Yeah. Yeah. Good.
Yeah. So in my standard formula of compound angle, I'm using A and B because normally in the question, A and B is not used normally.
Oh, I see. Yeah. Okay.
Theta, phi, something else is used. So we substitute those values. We'll say let A be equals to theta and B be equals to alpha. You get the idea.
Oh, yeah. I'll just do that. Yeah, just to make it clear to
so
myself.
We use different terms so that it can work most of the time.
Okay. Yeah.
Correct. So from the given question, we know one thing, that 3 is the value for R cos alpha and 4 is the value of R sin alpha. We substitute this. And if that is the substitution, then what is R equals to? R is equals to 3 square plus 4 square square root, which is 5, correct?
Yeah.
We derived this formula. And what is alpha equals to? Tan inverse of what is sine? 4, right?
4.
Sine term is 4. 4 divided by 3. So you have to write 4 in the numerator.
Yeah.
And do the inverse, you'll get 53.1 using the calculator.
Oh.
So straight away, we got the result that this given equation is 5 times cos of theta minus 53.1.
Oh. Yeah. So it's just, yeah. So it's getting the equation into the format of R cos theta minus alpha.
Yeah.
Then from there, you literally got all your answers because we derived the formula for R, which was root A squared plus B squared. And then to get alpha, if it's cos, you do B over A. If it was sine, you do A over B.
Yes.
Done.
Yes.
Okay.
So now you can say what is the maximum value? Maximum value is 5, right? There is no horizontal shift, as you can see with the formula. So minimum will be minus 5, right?
Minus 5, yeah.
And range is between minus 5 and plus 5. The range is...
Yeah, range, it's y-axis, up and down.
Yeah, so minus 5, that is your range, correct?
Yeah.
So it is asking for range, so we can write down the ranges from minus 5 to plus 5. Is that clear?
Both included, yeah.
And phase shift will be alpha, which is right. As you can see, that becomes the phase shift. Is that clear to you?
Oh.
Right, 53.1 degree. 3 significant figures. Is that clear? So simple as that. Now the question is, part B, when do you get the maximum? So cos 0 is maximum, right? So to get maximum, I have to make this as 0, right?
Yeah.
Otherwise, cos value will be less than 1. So to make this 0, theta should be equal to, just solve the equation, 53.1. It is maximum 53.1, right?
Yeah. It's very clear.
So that's simple. So if you are given an equation, easily within 1 second, you say R is what? 3 square plus 4 square square root. And tan alpha is ratio of the, you get the idea.
The sine of, over. Okay. Yeah.
So you have understood the first example, right?
Yeah.
So it is very clearly written what is the sine value, what is the cos value, just divide and get your result as we did. Now let's look into the next example, which is 5 cos theta minus 12 sin theta, correct? So first thing first, let's do the substitution. So since we want this to be in the terms of R of cos theta plus alpha, this is minus, that means we'll have plus alpha, right? Imagine, for sure, correct?
Oh, okay. Yeah.
cosine formula is such, compound angle formula, right? So 5 should be substituted as a cosine value. So r cos alpha is 5
Mhm.
and r sin alpha is 12, not minus, but 12 plus, because that minus will be taken care by the formula itself.
Oh, I see. Okay. You just write that down. Yeah, got it.
Because see, let's remember what is cos theta plus alpha will be equal to. It will be cos theta cos alpha
Cos alpha
minus
sine theta sine alpha.
So we only need to substitute that sine alpha as number itself, right? Not the sign, because we have taken care of sign. You get the idea?
Yeah, because it's in the equation. Got it.
It is in the
Yeah.
equation. So not minus 12. So I want to correct that. So this coefficient is 12. The other coefficient is 5. And both are related to r sin alpha and r cos alpha, because we want term of the equation within cosine terms, right? Cos of theta plus alpha. Is that clear?
Yeah.
Now from here we get the value of r, which is square root of 5 square plus 12 square, which is 13. And alpha is the ratio of these two. 12 over 5, we get 67.4 degrees. And so we could write our equation as 13 cos theta plus 67.4 degrees.
So if I used the I know it's not right, but like if I did theta minus alpha, would I just have to include the minus?
Yes,
into
yes,
the equation?
yes.
Okay.
So what I'm trying to say is, you know the compound angle formula, right? So accordingly, use your formula.
Okay.
Which one?
According to the question. Yeah.
According to the sign. So that you don't have to write minus inside. You can
because it's not nice dealing with negatives. Yeah.
Avoid. Many times they will restrict the, this time we have given plus and minus. So we were as expecting both. It is okay in this.
Yeah. Okay.
Now the question here is, how do you find the maximum? Tell me, what is the maximum value? You will equate to 0 this term, right?
Yeah.
We get a negative angle, 67.4.
But they're asking for the
minus 90%.
Oh, yeah. Because when you think maximum, you're thinking like has to be positive, but this is the angle theta. So when you go on the graph,
So
it'll be positive.
Yeah, it started earlier, right? So it's This is alpha. Right? This is the value of r. So that is how your function is. So we have just sketched the graph of this particular function. It looks like this. Is that clear to you?
So is the maximum and minimum for that one 13 and minus 13?
Yes.
And then, okay.
Correct. Yeah.
Got it.
This is minus 13 here.
Oh, okay.
R value. So in general, there is no shift vertical, but there is a horizontal shift, right? For all these simple harmonic motion equations.
All right. Okay. Would there ever be questions where there is upward as well?
We could make, but
Is
not
it
in
just
general.
not?
If you are given any form which is like a cos theta plus or minus b sine theta, in that case there is only horizontal shift, no vertical shift.
Right.
So this is equals to r times cos of theta minus
alpha.
Yeah, in general.
But if it's plus, it will be a minus theta. If it's
then
a
alpha
minus,
will be negative value. Yeah.
Plus alpha. Okay.
Yeah. So let me write like this. Like now it is okay, right? If
Yeah,
it is plus here, then minus. If it is minus, then plus.
Oh, I like that. Yeah.
Correct?
Let me just do that on mine as well. Okay.
Accordingly, you use your equation. So if I have minus here, I'll use already plus. Correct?
Right.
We will not get minus angle and make it minus.
No.
We will not complicate, right?
Yeah, that's complicating. Yeah.
Yeah, that is
since the other compound angles equation.
Yeah,
because the option's there, you might as well.
Yeah. So in this first case, since it was plus, do you see this plus? I use minus.
Yeah.
And so we'll work with positive values, avoid negative values.
Yeah.
I like that. Negative values gives a lot of problem. I will show you the problem also.
Okay.
I didn't want to get into that right in the beginning. I think in one of the examples, I took minus, and just to show you, it becomes complicated,
Yeah.
confusing. Now, again, let us take another example. This time we have sine and cosine. First, we have written sine, then we have written cosine. Is it okay?
Yeah.
But the equation says you have to write in terms of sine. You get the idea? Now,
And it's plus alpha.
yeah, sine theta plus alpha. So sine equations are sine A plus B is basically equal to sine A cos B
Plus
yeah,
cos A
B,
cos sine B.
sine.
Yeah.
But if that is negative, then this is their correspondences, they are same. Correct? Is it okay? Those
Yeah.
are the formulas. In our case, what do we have? We have positive here, right? And positive here. So everything, we are working with this positive and this positive. Is that clear?
Right. Yeah.
All positive. So square root 6 should be substituted as cosine.
Cos B.
Cos. Do you see that?
Yeah. Because we got the sine
We
theta
have to
there.
get sine cosine. Sine cosine. Is that clear to you?
Yeah, very clear.
So square root 6 is written as r cos alpha. You get the idea.
Yeah.
And
So does that mean
yeah.
root 3 would be r sine B or alpha?
Yes, yes, yes.
Got it.
So I have again derived the whole thing, going all the steps. But anyway, value of r is clear. A square plus b square square root, right? So 3 plus 6, 9. 9 square root will give
3.
me r value is 3. Done?
Yeah.
And the value of alpha is the ratio of sine coefficient is square root 3, right? So because we substituted, right? So square root 3 over square root 6 is r sine alpha over r cos alpha. So tan alpha is 1 over square root 2. Alpha is tan inverse of this, which is 35.3 degrees when you calculate.
Clear. And then you just substitute it into the format of the r sine theta plus alpha.
When is sine maximum?
Sine is maximum when that theta plus 35.3 equals 90. 90, because this is not a cos function, so it's not 0. Yeah.
So equate to 90, find theta, right? So you get 4.7, and that's the diagram for you. Is it clear to you?
And if it was flipped or anything, then when we find our r value, because the root of 9 can be plus or minus 3, you would just use the minus if it was flipped in the x-axis. Okay, cool.
The answer to the question remains same. I mean, whatever you do, whichever you do. But in this case, we had no option because we were given that the left-hand side is r sine theta. The right-hand side is r sine theta, right? So we have to follow the sine terms. Is that clear?
Yeah, very clear.
Yeah. So last question. Can you tell me what will you do? But this time, you see, we have sine and cosine, but we want cos. You see that? So yes.
Sorry, just so would the question tell you if they want cos or sine?
Yes.
Or if not, you choose cos because that's the standard.
Yes.
Okay, got it.
May tell you, may not tell you.
Right.
Those are two different types of questions.
Oh, fun. Okay.
Not
so
telling you. So what will you do? What will you do? Tell me.
Okay, so given that 2 sine theta minus root 5 cos theta equals minus r cos theta plus alpha. Okay, so can we quickly write out the cos A plus B?
Okay. So in this case, it will be cos theta minus sine theta.
Sorry. Yeah. Okay, so that means
that is inside term, right?
Yeah. I'm trying to like substitute. So we got 2 sine. Oh, because the order is really weird. Okay, that means minus root 5 cos theta. So does that mean my root 5 equals r cos alpha?
Yes.
And 2 equals r sine alpha.
Correct. So when we want to write it in terms of cosine, cos coefficient should be substituted for cosine, right?
Yeah.
Sine should be substituted for sine. Is that
sine? Yeah.
Now, this part is correct. Now, the question also gives you a hint. It is minus of r. So when I began solving this, what I thought is that it's a good idea to write this equation, which is, because if you substitute, now you did the substitution, right? Let's begin with let 2 be r sine alpha. This is what you told me, right?
Mm.
And square root 5 be r cos alpha. We made the substitution in our left hand side. We got this equation r sine alpha sine theta minus r cos alpha cos theta, correct?
Yeah.
Taking minus r common, so I'm taking minus r common to make the cosine terms come first.
Oh, okay. Like in the question.
Like in my expansion.
Yeah.
And sine terms come later, and I got the minus sign in between. You get the idea?
Oh, right. Okay.
Now what we have this as an expansion of cos theta plus alpha, right?
Yeah.
So I also flipped the order just to make it absolutely clear. I wrote cos theta first, sin alpha later. Do you see that? Flip the order so that it flows, right? Sin theta, sin alpha, cos theta, cos alpha. You get the idea?
Yeah.
And clearly, the inside term is cos theta plus alpha, right?
Cos theta plus, oh yeah, because that's the one that you wrote there.
Outside is minus r. And what is r equals to? Square root of?
Square root 2 squared plus root 5 squared.
Yeah. And
which
then we
equals
get
9.
9.
And then square root of that 3. Yeah.
Correct. And when we found to find the tan theta, we'll take ratio of these two, right? Sine on the top, right?
Yeah. So 2 over root 5, and then tan inverse of 2 over root 5 is 41.8 degrees, like you've shown, and then you just sub those in to the format they're asking for. So yeah, minus 3 cos theta plus 41.8 degrees.
Correct.
And that means the graph, so it reflected in the x-axis.
Reflected here, right? Do you see that? Reflected here. So that is minus because it reflected, correct?
Right.
So
as an amplitude of 3. Yeah, amplitude of 3. And minus 3 is the
I did a mistake here. This was sorry, this question was with minimum. I'm sorry.
Oh, okay.
Because it was flipped, right?
Right. And then it moved to the left 41.8 degrees.
Correct.
Units. Yeah.
Because this is with minimum, it flipped, right? So maximum becomes the minimum. Because, right? So it starts from earlier leads 41.8 degrees minimum value. Is that clear?
Yeah.
So we took up examples where we found the range, we found the maximum, we found the minimum. We use sine function, we use the cosine function. So these are the variety of questions which could be asked on simple harmonic waves. You get the idea?
Yeah.
Right. So that is kind of the summary for your lesson. You can actually try some questions from your book. And then you want to share some, and then we can solve them immediately.
Based on these questions.
Yeah.
I don't think I've printed.
You don't have? Okay.
Yeah, I don't know if I have them.
Don't worry. You read one from your book. Okay, read one from your book. We'll write it down and then solve it.
Okay. Wait, does this come under solving trigonometric equations?
Compound angle.
Oh, okay. Let's see. Some have a lot of cos and secant ones. I don't know if you've done that. Okay. Here, express 7 cos theta.
Let me write down 7 cos theta
minus 24 sine theta in the form of r cos theta plus alpha, with r being greater than 0 and alpha being in between 0 and 90.
Okay. Correct. So that is one of the question from your book. How will you do it? Because clearly you can see this is minus and that is plus. That means the signs are aligned, right? You don't have to think about it. Now tell me, how will you do it?
So first we can just quickly write out the one of those compound angle formulas, just so it helps me. So it would be cos A plus B.
So let's write cos theta plus alpha in this term itself, right?
Okay, so cos sine alpha theta, sine alpha. Okay. So we got cos theta. So r cos alpha equals 7.
Yeah, let me write down r here. Then r will get multiplied here, and r will also get multiplied here. Clear?
Okay, yeah, that was clear.
R cos alpha is equal to 7.
7 and
r sine alpha
equals to 24.
24. No need to write minus because minus is common. Do you see that?
Yeah, it's already there in the equation. It's really nice to not deal with it. Yeah. That's good. Okay, so to find r, you just do 7 squared plus 24 squared square root, which is where the calculator comes in handy. And 24 squared add 49, 625. So answer is 25 for r. And alpha is tan inverse of 24 over 7, which is 73.7 to 3 significant figures, 73.7. And then you simply just sub it in. And we know it's in the domain because it says alpha is in between 0 and 90. So then you just answer it by subbing in. So 25 cos bracket theta plus 73.7 brackets. Oh, that was like 4 marks.
Do you see that?
Yeah.
So any question like this on simple harmonic motion can be easily done by adopting these steps. And I like your approach that you know the formula, doesn't matter. Write it down, okay? Write it down. Then it becomes absolutely clear what should be the substitution, right?
Yeah.
Write down the substitution and then calculate the values, right? You're done.
Because I know, like, obviously, even you're like really good at just obviously looking at it and knowing that r cos alpha is 7. But because we know we have those 4 compound angles, just to be like specific to the examiner that this is the one I'm using, and then go from there because and the layout's really clear. So yeah. Thank you, sir. That was so helpful. When I started the lesson, it was so complicated, and you made it so easy.
Do you have any question where instead of cos they have written sine? Check your list.
Let's see.
If you have,
I do. I do.
Yeah? Okay, let's write down that question also.
So f of theta equals sine theta plus 3 cos theta. So given that f of theta equals r sine theta sine and then theta plus alpha.
Correct.
Where again r is greater than 0 and alpha is between 0 and 90.
Right. So yeah, greater than 0, alpha between 0 and 90, right? So alpha belongs to. Okay, done.
So let's just write out the equation one more time. Yes. So sine theta plus alpha equals sine theta cos alpha plus cos theta sine alpha. And then when you multiply everything like by r, so you would write r. So what you do, it means r cos alpha equals 1 and r sine alpha equals 3.
Correct.
Then r equals 1 squared plus 3 squared square root. So root 10. And then alpha equals tan inverse of sine alpha. So that will be 3 over 1. So just tan of alpha of 3, which is 71.6 degrees to 3 significant figures.
Correct.
And then you just sub in. So root 10 sine theta plus 71.6.
Done.
Oh, again, 4 marks. So that's good.
Four lines, 4 marks, done.
Yeah, and that was done so quickly. So I can save, and I have more time on other questions, which I might find hard because this one is just flying through it.
That is what is important, right? So it could be any combination of sine or cosine. You could
Yeah.
easily do it, right? So I hope you've learned the technique of solving any simple harmonic motion. We call it simple harmonic motion, compound
Yeah.
angle trigonometric formula application, right? And find very wide use. And always there is one question on this. So I hope you'll get it right all the time.
Oh, yeah, me too, sir. And also, like it's kind of like fun when you kind of do it and get into the gist of it. Because, yeah, I like obviously getting them right. So that's good. Thank you so much for making it like really easy.
Okay.
So, yeah.
Can you summarize today's learning?
Yeah, I can.
The benefit of our students. Yeah.
Yeah, for sure. So we kind of started with our 4 compound angles that we kind of derived last lesson. And it was more about this whole simple harmonic motion. Is that what you called it?
Yes.
Yeah. Okay. It's not really labeled like that in my book. That's why. But I like that. So I'll stick to that. And what we did was that the simple general formula that I wrote down is A cos theta plus or minus B sine theta will equal R cos, sorry, because that's the standard, and then theta plus or minus the alpha. So yeah, with that was our standard solution. And then we had a general solution for finding the R and the alpha, because those are the only 2 like unknowns that we need to substitute into our answer. So to find that, I kind of boxed it here. So R equals the square root of A squared plus B squared, and then tan alpha equals B over A if it's cos, and if it's sine, it's A over B. But you know that because tan is sine over cos. So yeah. And like we showed in those couple of questions that I just randomly like read out from my book, that are worth like 4 or 5 marks, and we answered it in like 2 minutes, like barely. Yeah. It was really good because we know our like formulas already. We just write it down in the format that best suits that question, and then you literally go from there, following all the steps that we learned in the lesson, and you get your answer. So it's really good.
Well done. So we'll end our class here. So I think next time, share with me whatever difficulties you have. Otherwise, we'll begin with a new chapter. Okay?
Oh, cool. Okay. Thank you so much, sir. I really appreciate it.
Bye.
Bye.